So like I said, we're going to do a couple sections tonight, and then we'll do some problems. Make sure you kind of know what's going on, so that I feel good, you feel good about walking out, and that you kind of know, we picked up what we need to know. So that's kind of my goal here. And do you have something? Those you took 60. You obviously using the same book, so that's not a problem. Does anybody not have a book? You don't have one? Not with you, but so you guys don't have books at all? What's this? Huh?
I just ordered it.
You just ordered it. Okay. So then, so I guess what you want to do is, at some point, just come up and take some pictures of mine, because it's the same as yours, and that way you'll have the assignment problems you can work on, right? I mean, even though it's not due till the 17th, but if you want to get a jump start on it, that'd be the best thing to do. Okay.
Online anywhere?
I don't believe so.
Not legally, no.
Well, there you go. Not legally.
The PCC website.
Oh, I can hook you up, man.
Hey, there you go.
I got friends.
You do. But they might charge. He didn't say it was free, did he? Okay. So we're going to do 4.1 and 4.2, which is solving systems of equations. I want to just kind of change this a little bit. There we go. Yeah, we're going. Okay. So there's actually 4 ways to solve a system of equations. All right, we're only going to look at 3 of them, and we're going to look at just 2 of them tonight. So one way is to graph it. Another way is to use substitution. And another way is to use what is called elimination. Okay, now on all the times that I've actually taught 65, and we talk about it as we move along, I say about probably 3/4 of the people, maybe even more, think that this is the hardest chapter in the whole course. All right, so they say once we get past this part, it gets easier. So that's what they told me a lot of times. All right, so I'm just telling you what they say. But all right, so solving systems of equations. Okay, we're going to look at graphing and substitution tonight. All right, I'm going to show you how to use that little Desmos thing on your phone so you can do some graphs that way. All right. As far as on a test goes, I think you should know how to do a couple by hand, and then after that you can use the Desmos app if you want to do your graphs. Okay, so a system of equations, basically a linear system, looks something like this. If we have y equals 2x and y equals negative 1/2 x, say plus 4, something like that, that's called a system. All right, these are 2 linear equations, and hopefully you know how to graph these either from your Math 60 course or some previous math courses. So let's do that anyway, but we'll talk about it. The best way to graph these, I'm just going to make a little hand graph here, like this. All right, is to use y equals mx plus b on it. Okay, so in this case right here, all right, remember that this guy right here, this number, what does that number represent? Yeah.
Does that represent the slope?
That's slope, yeah. That's your slope, right? Okay, so the number in front of the x, that's going to be your slope. Okay, So what would this other number represent? Anybody remember that? Yeah.
Y-intercept.
Y-intercept, great. So we're going to use those two things to graph. All right. Now I remember one year I taught 65, and I was doing this, and some people said, "Man, I've never graphed things like this before using this technique." They were using X and Y intercepts, or they were using a T chart. You know, use slope and Y-intercept because those other things are going to take you too long to do. All right. I know you don't want to spend a lot of time doing your math stuff. So let's graph this one in kind of a little purplish here. So the slope is 2, y-intercept. What is the y-intercept of that first one if there's nothing there? 0, right? So I'm going to go to 0, put a little dot there. Okay. Now I'm going to use my slope. Okay. So at some point somebody told you that this 2 can be 2 over 1, like that. So what is slope actually equal to? How do I graph from there? Yeah. Yeah, 2 over 1, right? Okay, so it's rise and run. Good, that's exactly what slope is. It's rise over run. Okay, so then I'm going to go 2 up, 1, 2, run 1, put a dot there. All right, and then I'm going to connect it with a line just like that. Okay, all right, cool. So there's my purple one. All right, now let's do this other one. Maybe I think this is a green. Oh no, that's more of a. Let's get a. Thought I had a green. This is a green. There we go. So that's supposed to be kind of a green there. All right, so we'll graph that one. Okay, in this case, what's the slope of this line? What's that first number there? So what this is 1/2, right? Okay, so that's our slope. All right, what's our y-intercept? 4. So I got to start at 4. So then I'm going to go up here to 4. 1, 2, 3. Oops, don't have a 4, but I'll just put a dot there. Now, what's my slope say? We'll do the same thing we did back for this one. So then what am I going to do here? Go down 1 over 2. Awesome. So we're going to go down 1 over 2, put a point right there. And now I'm going to cross them like that. So a system of equations is when these two equations are exactly the same. Okay, that's what that means, is that these are going to be exactly the same. So if I look at this, here's my purple one, here's my green one right here. Look at that line, that's nasty. Here's purple, here's green. Okay, where are they going to be the same at? Yeah, right where they intersect. Okay, now this is just a little sketch. Okay, so I'm going to kind of estimate. Let's see, 1, 2, 3. So I'm going to say 2, 3. All right. Now I don't know exactly if it's 2, 3 or not. Okay, because it's just a sketch. All right. If I want to get an exact answer, then I'll use something different to get an exact answer. But for this, all I have is a little sketch. All right. But this is a system of equations. So basically you have two equations, okay? And you're going to graph them and figure out where they meet. Right, that's what we're looking for. Okay, where they cross, they intersect, that's our answer. All right? So let's try another one here. Okay, so let's see. I was doing this color here. So we'll try another one. Let's make it a little different. Let's go with y equals negative 3x plus 6. And what if we went like this? 2x plus, let's make it negative, y equals negative 4. Okay? So, now I'm going to do this one. This one's in the exact form that I want because I have y equals mx plus b. That's great. That's the form I want. This one, though, not so much. All right? So, what do we have to do with this to get it to be in that form? What are we going to have to do to it?
Add it.
Add what?
2x to both sides.
Exactly. See? You guys are great. So, we're going to add 2x to both sides. So I'm going to get y equals 2x minus 4. Okay, now it's in the form that I want. Okay, so now I can actually graph it and find the answer. Okay, so then I'm going to come over here. See, all I'm doing is making a little sketch. So when you're doing your problems, okay, whenever you do those, all you need to do is make a little sketch, all right, and come up with an answer. And if you're off by a little bit, that's okay. It's okay, you know, when we use Desmos, then you'll find out how to get an exact answer. But for right now, we're just making little sketches and come up with approximate answers. Okay, and I'm okay with that. You know, you don't have to, I mean, if you want to get some graph paper or whatever, you can do it. If you want to get a ruler and be all that precise, I guess you can, but you don't need to. We're just getting some approximate answers here. So let's go ahead and graph this one. Let's see, I'll pick some orange for that. Oops, didn't get the orange right. There we go. Now I got orange. So, what's my y-intercept on this first one here? 6. 1, 2, 3. Notice I'm going to the y-axis. 1, 2, 3, 4, 5, 6. See, I don't even have enough there, but I'll put it that point there anyway. Alright, because I know that's 5 and 6, so I'll just go extend this out a little bit. 5, 6. There we go. What's my slope say? What do we got going on there? Down 3 over 1. Sweet. So we're going to go down 3. 1, 2, 3 over 1. Okay, put my point there. Hopefully, this is how you graphed a whole bunch of lines in Math 60 or wherever you took your... And you're really good at this because it's going to make your life easier. Okay, so there's that one. Alright, let's see. Then let's pick... I'll pick this red here for this one. So we have 2x minus 4. Alright, what's my y-intercept in this case? Negative 4. So I go down to negative 4 on the y-axis right there. What's my slope? Up 2 over 1. Good, 2 over 1. So we'll go up 1, 2 over 1. There it is. Draw a line. Okay, there's my intersection point right there. I'm not even sure what that is. Alright, but again, all I'm doing is just estimating it. Okay, so let's see. It looks like it's about 2. Not quite 2. Maybe if I want to go 1.8, I don't know, but it's not quite 2. So I'll go 1.8, comma, and maybe 0.5. See, so I'm not even, I'm just guessing because I'm not exactly sure where that is. Alright. But I know that's where the answer is right where they cross. Okay, so I'm going to estimate it. If you would have put 2 and 0.5, I'm not going to mark that wrong. Heck, that's pretty close. Alright, your graph might look completely different. I mean, it might not completely different, but look different than that, depending upon how you set your scale and if you used graph paper or not. Okay. So that's a system of equations, and that's what it looks like. So now, let me show you how to do it using that app, because I know you're wanting to see it. Alright. The only thing is when I do that, I can't record it on here. So, because I have to jump into this tablet won't access the internet. I think it's all locked up or something. Won't let me do it. So let me go. I'm going to go this way and back into this. Okay, and let's see. Oh, here we go. I'm surprised it's not on here, but we'll go into Google. Okay, and I'm just going to do a search. I don't want that. Oh, you bum. Maybe it's not. Maybe it's locked. Let's see if I can get out of it here. Oops. I had it, but then I lost it. There we go. Okay. So what I'm going to do is go into something called DESMOS. So if you go into your phone and you do a search on DESMOS, all right, when you do that, you'll get this, okay, and you want the graphing calculator. So it's DESMOS, Okay, that's what we're looking for. And there's actually a calculator on here. All right, this could be like one of your best friends here, and it's free, well, for now anyway. There we go. All right, and that's what it's going to look like. Okay, so there is an app you can download. I've never actually used. I've always used the internet version, even at home. I just use the internet version, but it's here. So if you want to do anything on the calculator, you just type stuff. So if we wanted to go 8 times 9 divided by 7, okay, it just tells me what it is. I don't even need to put equals. It tells me right there what it is. So it has a calculator built right into it, which is pretty darn nice. All right, you can get rid of that by just Xing that out. You can do squaring. There's squared. Okay, you can do square root stuff. I mean, you can pretty much do anything you want calculator-wise on there. But what's nice about it is that I can do some graphing, and I can figure out exactly where things cross. So if I want to go back to those problems that I just did, all right, I can type it in. So I'm going to go y equals negative 3x plus 6. You can see it's graphing it right there. All right, and then I'll come down here and I'll put the next one in. Y equals 2x minus 4. So now, look, that wasn't even really close. It says the answer is 2, 0. All right, so if you take your finger and you tap right on that where the intersection is, it's going to tell you what the answer is. It says it's 2 and 0. Okay, so I had like 1.8 and 0.5, so see, I was off a little bit. But that's how nice this is. You just type it in, it graphs it, you hover over by it, and it tells you what the answer is. Okay, it's that good. All right. You can change the color of these things by just holding this down. You can get any colors that you want. Okay, so that's pretty much it. It's pretty easy to use. All right.
Does it show you the kind of mechanics of it? Like if you put it in the other form we were using?
Can you graph it in without solving it for y? Is that what you're asking? Correct. Actually, you can. Okay. I usually don't show that part, but yeah, you can. Okay. It's pretty slick. All right. So let's try some more here. So I'm going to kind of bounce back and forth a little bit. Sorry, I got to do it this way. Okay, I'm just looking at some problems. And again, this is as long as you can do some by hand, that's fine. And then you can use your decimals for the rest of them. And I'll tell you on a test or something, I'll say, hey, can you do these ones by hand? And then you can use your calculator, smartphone, whatever, for the rest of them. Let's see. Most of them, it looks like we got to figure out, we got to solve them for x or y. They're pretty straightforward, but let's do a couple of them anyway. Here we'll go like this, and then we'll do one like, actually I can just leave this as a 2x. There we go. Hey, let's put a number in front of this y here. Sorry. That way it'll make it a little more interesting. Okay, so then here's a system. This is probably harder than almost anything you're going to get. So we have 4x minus y equals 3 and 2x plus 3y equals negative 8. And we're going to graph these. All right, so let's say that, I don't like decimals for some reason. I'm just going to do them all by hand. Okay. If we're going to do that, then we got to solve for y. We got to solve for y. So if I solve for y on this one right here, what do we got to do first? Subtract 4x. Very good. So we're going to subtract 4x here. Move this guy over here. Move this over here. So I have a negative y equals a negative 4x plus 3. Okay, but we can't have a negative y. That wouldn't be right. So what do we got to do there? How do we get rid of negative y? No, heck, all we got to do is change that to a plus. But if we change that to a plus, what do we got to do here?
Change it to a plus.
And change that to a... That's right. See, so all we got to do is just go plus, plus. Oops, now that's a minus. Okay? So that's done. Okay. Now let's do the same one down here. All right, we got to solve for y. So what are we going to do first? Subtract 2x. Very good. You always subtract the x first. All right. So I have a negative 2x minus 8. But then I got a 3y, and I don't want a 3y because that's not helping me. So what do I got to do to get rid of that 3? Yeah, we're going to divide by 3. Awesome. So we're going to have y equals negative 2/3 x minus 8. So now I have my two equations. I have this one here, all right, and I'll do this one here, and this green down here. Okay, so we could put these in the decimals right now. I bet you could put those in. It would graph it. You could tap on it, get an answer before I almost probably get done putting down the little graph thing here. All right, that's how fast you'd probably do it. So I'll put this here. Go 1, 2, 3 out this way, and you get a more accurate answer. Even if you got your little ruler out and stuff like that, you probably wouldn't get as accurate answer as a Desmos gives you. The only time it does fail you, I mean, as far as accuracy, is it just rounds it. Okay, so let's see. I got here. I'll do the red one. I got negative 3. There's my starting point. I'm going to go up 4. 1, 2, 3, 4 over 1. Draw a line. There it is. Okay, the green guy here. I'm going to start at negative 8. Oh my goodness. Way down here. 4, 5, 6, 7, 8. Got to go up. Oh, down 2. Oh my goodness. I'm still going down. Down 2 over 3. Like this. Where's my negative 8? 1, 2, 3, 4, let's see. 1, 2, 3, 5, 6, 7, 8. There it is. There's my line. Right here. Okay, I need to extend this line. Alright, and there's my point. So I'm thinking negative 1 maybe. 1, 2, 3, 4, 5, 6, 7, 8, 7 maybe. Could be the answer. Okay, but again, it's just an estimate because I don't really know what it is because it's such a sketchy little graph. Alright, it's not real accurate. So I would, if I went into Desmos, so I would get it. All right, so I think that's what I'm going to do. So I'm going to jump out of this now. So I can come back to it though, in case you didn't get it. All right, let's go into this here. Show you how this works. Okay, get rid of this guy. Get rid of this one. Here we go. Y equals. So I got to put in 2/3. So I'm going to go negative 2 divided by 3. All right. Now, you want to make sure that the x is not down here. So then you should tap this, put your x there, all right, and then go minus 8. Because you don't, otherwise it might think that your x is down here in the denominator. You don't want that. So make sure that you just tap over or use the arrows. Okay. Now I'm going to come down here, put the other one in, y equals. You know what I did do? I think what I didn't do on this one. Doggone it. Doggone it. I see I made a mistake. Nobody said anything. This. Where's it at? Here it is. Come on. This is supposed to also be divided by 3. The 8 was. Oh, that was bad. So let's change that. Okay. Completely. Rats. So this is really supposed to be 8 over 3. So that's 8/3. So that's just a little less than negative 3. Right about there. And then I'm going to go down 1, 2 over 3. So that changes the point quite a bit. Sorry about that. I don't even know. See, it's so close, it's hard for me to tell what it is. So I think it's like maybe 0.5 and 3 maybe. Okay. I don't know. That's what I'm thinking. That's why I want to use something different that's a little bit more accurate than my sketch there. So let's try it now. Okay, so now I have this I got to change because this isn't right. So let's start all over. So I'm going to go here. I'm going to go like this. I could go negative 2 divided by 3x minus 8 divided by 3. You could do it that way, or you could go parentheses on negative 2x minus 8, arrow past that, divided by 3. See, it's the same line. You can see that the purple one and the black one are the same one. They went right over the top. So you can either enter it this way, or you can enter it this way, whichever way you want. I'm going to dump that one for now. And then I'll put in the other equation. Hopefully I did that one right. Y equals 4x minus 3. All right, and there's my answer right there. So you can hardly even, oh, it's 0 and negative 2.667. So, oops, I bumped it. So in this case, okay, you're getting an approximate answer here, because that's actually negative 2 and 2/3. Okay, because it's rounding it. So it was actually negative 2 and, or not negative 2, but let me go back to, what was it, 0? I think in 2/3. Oop, oop. There it is. 0 and negative 2.6 repeating. Okay, so that's really what it turned out to be. All right. Any questions on that part that we did there? Are you able to access it okay? It does mostly, yeah. It's pretty slick, huh? Yeah, it's pretty nice. Okay, couple more things and then I'll give you a little break here. Go back to this. There will be a couple of problems where they're going to have ones like this, okay? They're going to say, what if you have like a x equals 2 and a y equals 5? All right. These so x equals 2 is right here. Here, let me graph this line in red again. There, that one's right there. Put this one in this color, whatever this is. 5. 1, 2, 3, 4, 5. Okay. There's my answer right there, okay, which is obviously 2, 5, which I could have got by just looking at that. These things here, that was going to be 2 and 5. Okay, so when you have lines in this form where it's just x equals 2, all right, it's just going to go vertical line at 2 because there is no slope. The slope is undefined in that case. Y equals 5. Y equals 5 right there. Okay, there's where they cross at 2, 5. Y equals 5, the slope of that one obviously is 0 because it's flat. Okay, so it's a horizontal line which is 0 slope. So you can graph those, but you can just look at it and get the answer. You don't even have to graph them. You can just say, oh, here I can find it, get the answer. All right. So you will have a couple like that. Otherwise, I think they're pretty much what the ones we've been doing. Okay. Let's do one of these and I'll get you out here. So if you take a look at, I know some of you don't have books, but let me give you, I'll just do one like, so like number 1 says this, 2, negative 3, and it gives you two equations, 2x plus 3y equals negative 5 and 7x minus 3y equals 23. And the question is, determine whether this is a solution to these two. Okay? So we want to know if 2, negative 3 is a solution to that system. All right, well, we could graph it, I guess. You could. But really, all you really need to do is just take this number and put it in there here and put this one in here and see what you get. So if I do that, I'm going to get 2 times 2 plus 3 times negative 3. See what I get? That's 4 plus a negative 9, which is negative 5. Hey, that works there. Let's try it down in this one. Oops. 7 times 2 minus 3 times negative 3. So I get 14 plus 9. Hey, that works there. So I guess this, yes, this is a solution. Okay. Since it works in both of those equations, it's good to go. So if you would have got one of them not to work, then you would have said no. But since it works in both of those equations, even though you're getting different numbers, negative 5 and 23, that's okay because that's what the equation says you should get. All right. So that would be a yes. All right. So you have a couple problems like that. The rest of them are going to be graphing things. All right. Any questions on the graphing stuff?
Do you want us to show our work on the homework, or do you just want the answers?
So here's on your homework, you know, I'm not going to get too excited about you showing your work. I mean, that's completely up to you, whatever you need to do to get it done, right? Okay, because I'm just going to look at the answers, kind of. On a quiz or a test, those questions are going to be worth more. So the more work you show, the more credit I can give you if you just make a little mistake, right? So it's beneficial for you on a quiz and a test to show work, but on the homework, probably not so much. All right.
Sounds good, thank you.
Any other questions or anything? All right, so maybe about 5 to 10 minutes or so we'll come back. I think we'll be done about 8 o'clock-ish. Okay, pretty dang close to it, maybe a little before. All right, but take about a 5-minute break, I guess. The sooner we get back, the sooner we get going again. Okay, so I'm going to show you how to do the last thing here, solving systems by substitution. All right. To be, honestly, substitution probably isn't the best way to solve a system of equations. I kind of think that the one we're going to learn on Wednesday is better. But if you were to take more mathematics and you solve different types of systems, then substitution is actually better. Okay, so for linear types of systems, probably not so much, but for other types, it's sometimes better. So let's talk a little bit about substitution, kind of how that works. I definitely want to give you guys a chance to do some problems too, so you can have a little bit of access or have some practice on it before we leave. So let's do this. Let's start off with something like this. Let's go x plus y equals 5 and 2x minus y equals negative 8. Okay, so we're going to use substitution. So basically the idea is we're going to take one equation and put it into the other equation. All right, so we're actually going to just take this and substitute it, which is why it's called substitution, and we're going to put it into the other one. That way we're forcing the equations to be equal so we can find that intersection point. So the idea here then is we're going to take one of these variables, okay, in one of these equations, actually, it doesn't matter which one we pick, and we're going to solve for it. In most of the cases, you've been solving for y for a while now, but in this case, in substitution, it doesn't matter. You can solve for x or for y because we're actually not going to graph it. We're going to replace it. So I'm just going to go ahead in this case and solve for this x right here. I don't know why. Just feel like that's what I want to do. So I'm going to solve for this x. So I'm going to move this y over to this side. So I have x equals 5 minus y. All right. And then I'm going to take that equation here, okay, and I'm going to substitute it into this. So since I solved for x here, that's where I'm going to put it. So I'm going to take this thing here and put it right into there. So we're going to take this and drop it right into that one right there. So I have 2 times 5 minus y equals negative 8, right? Because I'm putting that in here, so that's going to go there. This minus y goes there, that 8 goes there. So now this equation just has one variable in it, right? And it's fairly easy to solve from there. So we're going to distribute, go like this. Okay, and then I'm just going to kind of keep working this out here. All right, I'm going to combine those. And usually I kind of just make things up, so they hardly ever turn out. But by gosh, this one did. How about that? That's crazy. Usually I get like decimal numbers and stuff. Okay, so then I get y equals 6. All right, so I've substituted the other equations. So I took top one into the bottom one. Okay, solving equations, wrote out my steps, just solving equations, distributing, combining like terms. Okay, things he did in your previous math course there. Okay, I got y equals 6. So I'm feeling pretty good. Got that done. All right, but you're looking for an intersection point. Okay, so you not only need the y, you also need the x. So then what we want to do is come back up to this equation here, okay, and put that y into that equation so I can figure out what x is. So I'm just going to change colors here first to get a contrast. So we're going to go x equals 5, minus 6. There we go. So we get x equals negative 1. And now I have the answer, negative 1 and 6. So if I took these equations and I graphed them, all right, and I checked them, I should get negative 1, 6. All right, so I can tell you that your quiz and your test, that's what I'm going to ask you to do. Is I'm going to ask you, hey, can you solve this equation by substitution and then verify your answer by graphing? Okay, you're not going to have a lot of questions where it's just going to say, graph these and find the answer. I would rather you figure out the answer by graph or by substitution and then check your answer by graphing, because it's so easy to just put those equations in the decimals and check your answer, all right, and see if you get it right or not. Okay, so that's substitution. All right, so let's try some more. All right, here we'll do some more. So let's go with 2x plus y equals, there's no way I'm going to get two of these right here. X minus 3y equals 12. So something like this. All right. So there's my equations here. Here's my system. All right. I have some options here of using substitution. I could either solve for this y or I could solve for this x. Why would I not want to solve for that y?
It's negative.
Not only is it negative, what else are you going to have?
3 of them? Fraction.
Fraction. If you solve for this y, you're going to have to move that x over and then divide by 3. Okay? You don't ever want to do that, because then you get a fraction, and hardly anybody in the world likes fractions, okay, except for maybe some math guys. But most of the time people don't like fractions. So don't solve for this one, and don't solve for this one. Pick ones that are easy to solve for. Okay? And I think every problem in here that I'm looking at you can solve for an easy one. Okay? Alright, so I'll let you pick. You want to solve for this y, or you want to solve for this x? What do you want? The x. Okay. She says, I want to solve for the x. Awesome. And it doesn't matter. You're going to get the same answer. So if we're going to solve for the x, then you got to tell me what we're going to do.
Oh, sorry.
That's okay.
You can plus 3y
All right, cool. So we're going to add 3y to both sides like this. And what are we going to get?
X equals 12 plus 3y.
Exactly. We're going to get x equals 12 plus 3y. That's awesome. So now we're solved for x. Okay? We use this equation. So where are we going to go with this? Where's this going to go? Into where?
2x plus 1.
Up here, right? We solve for this equation, so we got to put it into that one. All right, so now we're going to take this and we're going to put it right there. So we're going to have 2 times 12 plus 3y plus a y equals negative 8. See, now all the x's are gone, and it's just a nice little equation to solve for. Okay, so we distribute that. All right, hopefully you're really good at this, because Desmos won't do this for you. You actually got to do this stuff here. See, I knew I'd get one that didn't work out. Subtract 24, but that's okay, because you know, very rarely do things in the real world ever come out to be exact answers. Only in textbooks that are written by math guys like this one was. Sometimes he gives you decimals, but most of the time everything works out. So I got 32 over 7. I'm going to change that to a decimal. I don't know. That's not going to be very good. 4.45? 4.57? Okay. Yep, that sounds about right. So there's my y point. Okay. Feel pretty good. All right, you got that. You think that's the answer, but what do we got to do to get the answer? Yeah, we got to put that in right here where you solve for y. So, or solve for x. Okay, so we got to put that right in up there. So I'm going to draw a little arrow here. X equals. Now, I would use my calculator. Okay, and I would just type this in. I would just say, would you do this for me, and ask it to do that for me. X equals, I just go 12, okay, plus 3 times negative 4.57 and see what it gives me. X equals, so what do we get? Anybody got it? I have a calculator on here. It's not very good.
It can give me 1.71 for the answer.
Yeah? Well, we'll try it out here. 12 plus 3 times 4.57 negative. Let's see what it does. Did you get 1.71? Is that what you said? Sweet. Okay. All right. So there's my x and there's my y. Now, whether you write it as a point or not, again, you know, I'm not going to mark that wrong. You know, you got both answers there. I can see it, so that's good enough for me. All right. I mean, I know you know it's probably going to be a point. All right. Hopefully you do. Okay, but that's how substitution works. Okay, it's just really pretty. Take one equation, substitute it in for the other. Let's do one more. All right, and then I want you to do some problems so that we can do some things here. Let's see. Let's do one like this. I see there's one like this on there. 4x plus 3y equals 24, and y equals 2x minus 1. So then we have one like that. Okay. Here, I'll move this up a little bit so you can see it. So, now this one's an interesting one because what do we got right here? It's already solved. We don't even have to do that. Okay, it's already solved for y. So what are we going to do with this 2x minus 1? Just put it right, yeah, just put it right in there. That's nice of them to do that for us. 4, put that 2x minus 1 in there, plus 3y equals 24. Okay, we're going to distribute. And somewhere I messed up.
You put it in the
Yeah, I was gonna ask you.
Well, it's been a long day. So I put it in for the x instead of the y, and I almost did that twice now. There we go. Let's put it in this one. How about that? 4x plus 3 times 2x minus 1 equals 24. Okay, so here we go. Plus 6x minus 3 equals 24. 10x equals 27. Oh, at least this one's not too bad. I can divide by 10 and I get 2.7. Okay, so there's that answer. But again, you know, and a lot of times that'll happen where folks will get to this answer and they'll say, hey, I'm done. But you're not. You just, you know, you're kind of used to just writing this out and getting x equals and then going on to the next problem. But in this case, you can't. You got to find that point where they cross at. So we got to go back up to there, right, and put that in there, and then we can feel good about it. Get my calculator out here. 2 times 2.7 minus 1, 4.4 it says. Okay, so if I wanted to write it as a point, 2.7, 4.4. Okay, so let's say that was a problem that we would have to do. So then, as a test question or a quiz question, I would say, all right, hey, you did it by substitution. Now go check your answer and see if it's right. All right, so then you would pop down into, you know, you got Desmos out here. So you would pop into that. I still have it. Okay, get rid of this, get rid of this, get rid of this. And I would type this in. So I'm going to go y equals 2x minus 1. Put that in. Oops. What happened to my equals? 2x minus 1. Put that in. Come down to here. Y equals. Oh, here. Sorry. Back up. Here's a question that you asked about putting it in, right? So 4x plus 3y. Okay, equals 24. There it is. So let's see if I got it right. Did we get 2.7 and 4.4?
Yeah.
There it is. Okay, so you're feeling good, right? You did this on, if this would be exact like test or quiz question, I'd say do it by substitution, verify by graphing. You did it by substitution, you show me your work, you got it down, you go to your Desmos, you type it in, everything works out, you get the problem right, you're feeling good, all right? Going to get an A, you're all excited, you move on to the next problem, right? So that's kind of what we'd be doing. All right. Here we go back down to this. Any questions on that whole, how that worked out? Questions on substitution?
Can you show me how you, by hand, how do you check it by graphing?
By hand?
Yeah.
Sure. So you're just going to make a graph like this, right? Now, yeah, okay. So then let's see. You have to help me out. What was it? Y equals 2x minus 1, right? That was one of the equations, okay. And the other one was 3x, 4x.
Plus 3y. That's 3y.
So this one's not too bad. I can graph that one, right? It's already solved for y. So I'll go ahead and do that. Let's see, I don't know what color was in, but I'll just do it in green because that's real easy. So minus 1, that's my y-intercept, correct?
Yep.
Up 2 over 1, there it is. Okay, now I'll come down here and do this one. I call that one fire engine red. But I got to solve for y, right? So move that over. 3y equals negative 4x plus 24. So far, so good. Okay, divide by 3, divide by 3. Y equals. Now, see how I divided both of these by 3? Some people don't like that, but I've just been doing it for doggone years. So But I'll rewrite it for you in that form, because I'm just dividing both those by 3. You see what I did? Okay. Alright, so now I go to 8. I don't have 8 on here. 3, 4, 5, 6, 7, 8. Down 4 over 3. Down 4, 1, 2, 3, 4 over 3. Put a dot, cross it. Okay, so I mean, I'm getting an estimated point of somewhere between 2 and 3, and somewhere about 3 to 4. So see how I'm pretty close, right? It's not great, but you know, if you graphed it and this line was way over here and you were getting a negative, then you can say, oh man, I messed up somewhere. Okay, and that's what that's all about. You know, the graphing is to try to figure out, hey, where did I type it in wrong, or did I make a mistake someplace? You know, like me when I put it in for X, right, instead of putting it in for Y. Okay, what the heck did I do? Okay, so you can, that's kind of a verification for you. Is that good? Is that what you were looking for?
Yeah.
You're welcome. Any other questions on substitution before we do some problems here? Okay. So here's what I want to do. I want to, instead of actually doing some things out of the assignment, I want to switch it up a little bit. I'd rather do this tonight, even though I told you that's how we were going to do it, but I'm going to switch it up. Okay. So let's do this. I want you to solve these by substitution, and then I do want you to verify them graphically. Hopefully using Desmos. Now, if you don't have it, maybe you don't have a smartphone, or maybe you're not getting, you know, maybe for some reason, maybe the person next to you does, right? And then you can kind of use it, okay? So I'm going to give you about 5 of these to do, I think. And if you can do all these, then we'll go over them, okay? And we might be a little later than 8, sorry. We'll go over these, and then we're done. So let's do this. Let's do x plus, I'll try to make them so that they're not, because I said 8, so I feel bad. 10 and 3x minus y equals 6. So there would be the first one. Okay. So this way too, if you can do them by substitution and graphically, you can't kill 2 birds with 1 stone, so to say. That old expression there. Let's do one like this. If there's anything in here that's going to throw you off. I think we're okay. Let's not do 1/3. Okay. I'll make this smaller. Put 3 down here. And I'll put the 4th one over here. Okay, so let's try those 4. All right, so we're solving by substitution, verifying by graphing, and we'll go over them. Okay, and then we'll be done. If you have questions, ask me, ask people next to you. You'll learn a lot sometimes. And if you need pictures of the book or something, there it is. What they solve for here? X or Y? Solve for X? Okay. So if you solve for X, that means you moved the Y, correct? Okay, so we get X equals 10 minus 2Y. There that is. Substitute that in. And we get negative 30 plus 6Y minus Y equals 6. So what does Y turn out to be? Anybody got it? What does Y turn out to be? 1.8. Is that right? Everybody gets 1.8? No? So let's see, we got negative 30. I got plus 5Y equals 6. 5Y equals 36.
Yeah, that's what I got.
Okay. That's why we go over these. Not a big deal. Alright, I'm going to move this one to take this, move this down a little bit for now. I don't know what just happened. No. That was not good. There we go. Okay. Try this again. Alright, so we got 7.2. Okay. Put that in for right there. And what does X turn out to be?
4.4. Yeah, I got negative 4.4.
Negative 4.4. Sounds about right. Okay. And then when you graph it, did it come out good? Yeah? Does most of it? Good. Okay. Alright. I'm going to drop this one way down here. Let's see it because I messed it up. So it was 2x minus 2y. 2x minus 2y equals 8. And x plus 1/2 y equals negative 6. Okay, what are we solving for there? It's pretty obvious. What are we solving for? Yeah, we're not going to solve for any of those other ones, right? So let's see. X equals negative 6 minus 1/2. Okay, put that in up here. 2 times negative 6 minus 1/2. Y equals, oops, minus 2y equals 8. Okay, what did we get for y this time? Anybody get it? Oh, what did you get? Minus 8.6 something? 6.7? 6.7? Okay. That's negative, correct? Okay, we're good with that? Alright, there's my y. Now I'm going to put that in for my x. X equals negative 6 minus 1/2 times negative 6.7. What does x turn out to be? Something in the 9s? Negative 9.3. Okay. Desmos graph it. Should verify it. Alright. Cool. So we're zipping along here. Alright, let's look at this number 3. So 9x minus 3y equals 6. 9x minus 3y equals 6. And 3x minus y equals 2. 3x minus y equals 2. What are we solving for? Again, it's pretty obvious which one. Y, right? So y is equal to, now I have a negative y. So when I move that 3x over like that, we don't have a negative y. We can't have that. So what are we going to do? Good. We're going to change it to this. Okay. And where's that going to go? Where's this going? Yep. Okay, and I didn't hear anybody say anything. Alright. This happens. And what happens here? Yeah, those cancel out, don't they? And we get 6 equals 6. What the heck? Did anybody graph this? What happened when you graphed it? Anybody try graphing it? No? You just said 6 equals 6. This is a crazy problem. I don't know what's going on. Okay. Let's graph it. Okay, I'm going to put this in here. Here we go. So my first equation was 3x minus y equals 2. And my other equation was 9x minus 3y equals 6. Now watch what happens here when I put this in. Okay. So here's the orange one, right? As soon as I hit graph this one, what happens? Goes right over the top of it. It's the same. You're exactly right. Okay. So when you have a situation where you get what is called a true statement down here, 6 equals 6, it's what coming up here. When we get this, okay, and you graph it, and the lines are the same, then how many answers do we have? A whole bunch of answers, okay? So here's what you do. You go like this. You put some little squiggly here. You go x comma y in parentheses with a colon. The colon means such that. Alright? And then you pick whatever equation you want. So for example, I'll pick 3x minus y equals 2. What you're saying is that it's all the x's and y's that work in that equation. Okay, you can't say all real answers because it's possible that 0, 0 doesn't work. Okay? Because if we graph this, you're getting this line right here. It's not a point that's up here. It's not a point that's down here. It's just all these points. So that's why you go squiggly x comma y such that, and you can put any equation you want in there. Okay, so it is possible when you're doing some of these questions that you're going to get stuff like this. Okay, you're going to get the x's are going to cancel. You're going to get a true statement. All right, so be careful of that when you're doing these. Last one. Oh my goodness, here we go. Last one. X minus 2y. X minus 2y equals 7, and negative 4x plus 8y equals 10. Obvious, what are we going to solve for? X, right? So we're going to get x equals 7 plus 2y. We're going to put that into here. And something happened, and nobody said anything, but something happens again. Negative 28 minus 8y plus 8y equals 10. What happens to the 8y's? They're gone. And we get negative 28 equals 10. Does negative 28 equal 10? No. So what do you think's happening here? Did anybody graph these ones? There's two parallel lines, huh? Do they cross? So what's the answer? If they don't cross, there's no solution, no answer, right? No solution. So if you're working on these, okay, and you get a statement right here that says two things are not, negative 28 doesn't equal 10. Not here, not anywhere. Okay, that's no solution. You can graph them. Those lines are going to be parallel. They're not going to cross. Okay, so when you're doing these problems, and I put those things on there for a purpose, okay, be careful that you could get one answer. Okay, you could get a bunch of answers, and you can get no solutions. Okay, it might mention the words, I don't see it, independent or dependent. Don't worry about that. All right. That's it. Does anybody have? I did pretty good. Any questions on anything before we take off? Remember, this isn't due to next Wednesday, right? Because I'm okay. Get pictures of the book if you need it. If you want to ask me something, I'll be happy to hang out here to 8:20, okay, or longer. Otherwise, have a great evening. See you Wednesday. Thanks for coming.